Day 11 notes, and it's all about concavity. So we're going to talk about the 4 basic shapes of a graph. So there's 2 types of concavity, concave up and concave down. All right. When I like to think about concavity, concave down means the graph is cupping downward. All right. So for example, I'm just going to abbreviate concave down. All right. An easy example would be maybe a parabola opening down. I think of a parabola opening down is curving downward. All right, it's cupping down. All right, sometimes, your graph is just curving down. It might not be a whole parabola. It could be just kind of part of it. All right, but for example, this first graph right here, all right, it's curving downward. A way to think about, is it curving downward or not? Think about if it was raining on this graph. All right, the rain would just kind of fall down the graph and kind of fall to the ground. All right, whereas concave up, that would be like a parabola opening up. All right, if it was raining, that rain would kind of collect and fill up this parabola. All right, so then concave up, cupping up, it's like a cup that's facing upward that would collect water. All right, where concave down, if something was raining on it, all right, the rain would just kind of fall off the graph to the ground. All right, so I think it's really curving up, curving down. So this second shape is also concave down. It's kind of like the right side of a parabola that's curving downward. But the difference between these is, and I know these words are really, really tiny, they're written in here, all right, but right here, that word says increasing. All right, this graph is increasing. If you trace it from left to right, all right, my pen is going up, 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 up. It's increasing, where this one, all right, this word is really, really small, but it says decreasing. All right, this graph is decreasing. If I start on the left and I trace it as I go to the right, my pen is going down. All right, so they're both considered concave down, both of those highlighted graphs in orange, but one is increasing, one is decreasing. All right, the graphs on the right that are in red, these are cupping up. Think if it was raining out, all right, the rain would kind of collect in here. All right, same thing, this graph, all right, it's curved up, or in other words, concave up. All right, the rainwater would collect in there. Think of it as a cup facing upward. All right, and again, there is a difference between these. All right, this one right here is concave up, but this word underneath here that's hard to read, all right, says increasing. All right, if you trace this from left to right, starting on the left here, if you trace to the right, my pen is going up, 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 up until the end of the graph. So it's increasing, where this graph all the way on the right is still concave up, but this one is decreasing. If I start on the left and trace, my pen goes down, 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 down. All right, so that is decreasing. So that's kind of the difference between those. Those are the 4 basic shapes. They can either be concave up, concave down, and then either increasing or decreasing. All right, so a lot of times you can just look at a graph and know it's concave up, because if you have the idea, okay, concave up, that means curving up, you can just kind of tell. But you want to know a little bit more about, what makes a graph concave up, what is making it curving up. So we got to kind of understand the definition. So here it says a function whose rate of change increases, which means gets less negative and more positive as we move from left to right. All right, so let's review. You guys know average rate of change, or rate of change is just a fancy name for slope. It's saying the slope increases from left to right. All right, and we can kind of look at this using what we call tangent lines. All right, I think you guys have probably heard of a tangent line before, but probably with a circle. All right, in geometry, you probably learned if you have a circle and you have a line outside it that touches at one point, that would be a tangent line. Well, just like circles, any graph can have a tangent line. You can pick a point and draw a tangent line in, and you can just kind of look at that line and say, okay, what kind of slope does it have? That looks like it has a negative slope. All right, we could just pick a few points and draw in tangent lines, just mini lines. All right, they should kind of just skim the graph, only touch at one point. Sometimes they're a little bit tougher to draw in. Maybe that could be a tangent line. Let's draw another one at the bottom at this minimum. That's a horizontal. Then going up. And we can kind of analyze these tangent lines and look at what kind of slopes they have. All right, so going from left to right, starting with this orangish yellow tangent line on the left, that's a negative slope, and I'm just going to make up slopes that make sense. Let's say that is almost a vertical line. Let's say maybe that slope will be -10. All right, and then let's go to the green one. The green one is a little less vertical, a little more flat. So let's maybe say that slope is, I'm just making this up, maybe -3. All right, and then the blue one, you could even probably do rise over run here, down 2 over 2, -2 over 2 would be 1. All right, so let's say that slope is -1. And then the purple line, that's a horizontal line. Any horizontal line is a slope of 0. All right, and then if we go back to blue, this blue one is now a positive slope. If you trace from left to right, it's going up. All right, it's the exact opposite of the blue on the other side. So this would probably be a +1. And then green, let's say this would be a +3. And then yellow, again, if you look at the other side, it was -10. This has a positive slope, so +10. And I just made these numbers up, kind of looking at them. They should make a little bit of sense. But if you now analyze from left to right, tracing from left to right, my slope is -10, -3, -1, 0, 1, 3, 10. Those slopes go up. They start at negative, they go to 0, and then they keep going up, 1, 3, 10. All right, so your slopes are increasing. Anytime that happens, your graph will be concave up. It will start to curve up. So that's the mathematical definition that you want to know. All right, that your slopes will increase from left to right. And again, you still can use kind of this concave up. Think in your head that means cups up. Again, you can usually tell concave up or down just by glancing at it, but if you want to know the math behind it, it is all about these slopes. All right, the slopes from left to right, all right, will increase. They go from negative to positive. All right, so let's look at concave down. Again, you guys probably know that this graph that we're looking at right here, this parabola opening down, if it will let me draw on it. It's not letting me. This one right here. Okay, my pen now works. This graph right here is a parabola opening down. It's concave down, all right? And you can probably just tell by looking at it because it cups downward. All right, but again, we want to know the mathematical definition. Why does that shape happen? Cupping down. So look at it. It says its rate of change decreases from left to right. All right, and again, rate of change is just slope. All right, so if we draw in those tangent lines and look at the slopes, all right, if we look at them from left to right, they should be decreasing or going down. So let's do the same thing we did before. Let's just draw in some tangent lines. All right, and we could just make up some slopes. That's a positive slope. I'm going to say maybe that's a +3. Going to draw in another tangent line. Tangent lines just kind of skim the graph. All right, maybe this one looks a tiny bit flatter, but still positive. Maybe that's +2. Let's do another one right here. That's positive, but a little bit less. Maybe that would be a slope of maybe 1/2. Let's do one at the very top. This tangent line, that would be a slope of 0. Let's do another green. Getting kind of messy in here, but it would be the opposite. If this one was positive 1/2, this one is now sloping negative, it would be -1/2. Do one right here. All right, it should look like the same slope as this one if that one was +2. This one is -2. And if I do one more opposite the red, all right, this is a negative slope. So it might be something like -3. And again, I just made up these numbers, all right, but if we look at them from left to right, it goes 3, 2, 1/2, 0, -1/2, -2, -3. Those slopes are decreasing, all right, or in other words, going down. So that's why it's concave down. Concave down means if you look at your slopes from left to right, they decrease. That's the mathematical definition behind it. But what it will form is a graph that looks like it's cupping downward. Down. Some graphs don't cup up or cup down, all right? And think about if they're not curving up and they're not curving down, usually a graph like a straight line, all right? And it says a function whose rate of change stays constant. Remember, rate of change is slope, right? If the slope stays constant or you have the exact same slope all the time, all right, that would be a line. All right, so a graph that's a line, you can't say it's concave up or down. It would just be neither. And it says here in parentheses, lines have a constant AROC. Remember, AROC is average rate of change, all right, or slope. On a line, it doesn't matter where you look, what 2 points you pick, you always get the same slope. All right, so in example 1, it says highlight the parts of the graph that are concave down. All right, so it looks like the first part, this looks like it's cupping down to maybe about right there. Then it looks like it's cupping upward, maybe right here. Looks like it's cupping down, maybe to about there. And then it looks like it's cupping up. All right, so I think the highlighted parts are cupping down. The non-highlighted are cupping up. And you kind of just have to eyeball it. You know, there's not really a way to know for sure this is, you know, the point exactly where it stops. All right, if you highlighted a little more or a little bit less, that will be okay. I'm truly just kind of estimating where it changes. All right, something to point out, the points where it changes, all right, those are called inflection points. And it's just a good vocab word to know. Sometimes I like to label them IP. All right, an inflection point is just where your graph changes from cupping down to up or vice versa. All right, let's take a look at example 2. It says determine whether the function is concave up, down, or neither. All right, they aren't giving a picture, so we can't just look at, you know, is the graph curving up, curving down, is it a line? All right. So think about what else we just learned. The mathematical definition was about slopes, right? We said concave up means slopes increase from left to right. All right, we said concave down means slopes decrease from left to right. And if you need to go back, that's literally what these definitions say. Concave up, slope increases from left to right. Concave down, slopes decreases. All right, and then we said if it's neither, right, that's when your slope stays the same. That would be a line. So all the slopes are the same. So we just have to take pairs of points and find our slopes. So I'm going to take these 2 points, use the slope formula, y2 minus y1 over x2 minus x1, and we can plug in our values. -1 minus 0.5 all over 0 minus a -3. So we'd get -1.5 all over, we'd have a double negative there, turn to positive, over 3, all right, which really that's -1/2 if you reduce it. All right, so let's move on to the next point. Let's find the slope. Probably don't have to write our formula this time. 3 minus a -1 all over 2 minus 0. That's a double negative that turns to positive. You get 4 over 2, which is 2. All right, so right now it looks like our slopes are going up. We have -1/2 to 2, but let's just double check that that pattern keeps going. All right, let's find the slope of the last pair of points. 6.5 minus 3 all over 3 minus 2. You get 3.5 over 1, which is really 3.5. All right, so if we look at our slopes from left to right, it goes up, it goes up. So slopes are increasing. So we know our graph is concave up. So this graph is called f of x. We could say f of x is concave up, and we'll write how we know, since the slopes are increasing from left to right. That is how we know. All right, let's look at example 3. Sketch a graph of f of x. Determine the intervals for which f of x is concave up and concave down. Write your answers using inequalities and interval notation. All right, so we might have to get a calculator out. I don't know about you guys, but I do not know, exactly what this graph looks like. So I'd pull out your calculator, type it in, see what it looks like, and then we can just sketch a picture of it. I'm going to switch to my calculator screen so I can graph that. All right, so I type my function in. If I press graph, looks something like this. If you feel like you can't really tell, is it cupping up, cupping down, you could change your window and zoom in a little. There's a lot of extra graph on the left and the right that's blank. All right, so think left and right, that's your x-axis. Right now, our x min and max is -10 to 10. All right, we could change that. What if we made it like -3 to 3? Then we might be able to see a little bit more what's going on. All right, so let's try to draw a sketch of that. If you wanted to get an exact point, it looks like that point is 0, 1. We could look at the table. Yeah, that point in there is 0, 1. All right, but it looks like the left is cupping down and then the right is cupping up. So let's sketch that on our papers. Again, I just sketched this graph right here that we saw on our calculator screen. All right, and it said determine the intervals where it's concave up or down and write your answers using inequalities and interval notation. So I'm thinking this left side, all right, that looks like it's cupping down to me, where the right side, that looks like it's cupping up. All right, so we need to kind of write this in interval notation. So let's write, we think it's concave down. All right, we need interval notation and inequalities. All right, so this point right here where it changes, the x value is 0. All right, so you always say, if you're talking about the left side, all right, we're talking about x values less than 0. All right, to the left of 0, we're cupping down. All right, whereas concave up, this is happening on the right side of this point, all right, the right of 0. So we could say for x values greater than 0. All right, that would be using inequalities. All right, if we want to talk about interval notation, all right, we could say the left side is from -infinity to 0. I think -infinity is all the way on the left. All right, starting at -infinity all the way to 0. All right, that part of the graph is cupping down. All right, that's your interval notation. And then the right side is cupping up. We could say starting at 0, going all the way to this arrow on the right to +infinity. That part is cupping upward. So that interval notation would be 0 to infinity. So there's kind of 2 ways to express the answers. These 2 things right here, all right, mean the exact same thing. The first one is just an inequality. The second is interval notation. And same thing, all right, with the other right here, all right, they mean the same thing. Normally, you wouldn't have to write your answer 2 ways. They just ask us to, but the first one is an inequality, and the second one is interval notation. A point where a graph changes concavity. That's what we were talking about. All right, we briefly mentioned this before. All right, inflection points where it changes from concave up to down. All right, so it looks like, in this graph up here that we were just talking about, we could have labeled that point in the middle, 0, 1, as an inflection point. All right, that's just a good vocabulary word to know. If you take calculus next year, all right, they're going to talk about inflection points a lot. So just good to have on your radar. All right, let's take a look at example 4. It says, is the function increasing or decreasing? What does the scenario tell you about the concavity of the graph modeling? So it says after a cup of hot chocolate is poured, the temperature cools off rapidly at first and then cools off more slowly until the temperature reaches room temperature. So let's try to draw a graph of this. They want to know, is it increasing or decreasing? They kind of just described what's going on. We're talking about hot chocolate, its temperature, all right, really as time increases. So let's just say time and temperature of the hot chocolate. All right, so, hot chocolate is really hot at first. All right, the temperature, maybe starts up high, and then it says it cools off rapidly and then cools off more slowly until it reaches room temperature. All right, so I'm picturing something like this. It cools off rapidly and then slowly it goes to room temperature and kind of stays there. This is maybe what that graph would look like, right? It doesn't keep getting colder and colder. It would just stay at room temperature. So that's what the graph looks like. They want to know, is the function increasing or decreasing? Well, all you got to do is trace it from left to right. If you start on the left and you trace to the right, my pen is going down, 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 down. So decreasing. All right, and then what does the scenario tell you about the concavity of the graph? All right, you just kind of have to look at that. Is it concave up or down? Looks to me like it's curving upward, concave up. If it were to rain, it would kind of collect the rain inside the graph. So I would say, they wanted to know concavity. This graph is concave up. So you might just have to kind of draw a picture of it so you can see it and answer the questions. I hope you guys found this video helpful. If you have questions, please contact your teacher. Otherwise, have a great day.